Good afternoon and welcome to Colonial Williamsburg's Trades Tuesday presentation. Today we're in the Anderson Blacksmith shop and we're going to take a look at working iron and steel. Specifically, we'd like to do some work on some woodworking tools. Our last broadcast from here, we worked on some tongs for the blacksmith shop. So we thought we'd show you some of the tools that we make for our other colleagues. I'm Ken Schwartz. I'm a blacksmith here with Colonial Williamsburg, and joining me today in our work will be Mark Sperry, another one of the blacksmiths. And I'm going to let Mark talk a little bit about what we'll be doing while I start heating the material here.
Hi folks, thanks for joining us today. Today we're going to be working on some paring chisels like the one here in my hands. Ken has a bar of iron in the fire, he's heating up. So here's a finished example of the paring chisel that we borrowed from the cabinet makers. The starting material that we're going to use is again a bar of iron. Here's a piece roughly the size that we need to get to the finished product. So as you can see, there's going to be a lot of stretching of material or mass. This whole process that we use as blacksmiths is very sculptural in nature. We'll heat the material up to soften it, and then it's going to be stretched in a lot of different directions. The first step that we're going to focus on is actually going to be to make this little faceted section here right above where the handle connects to a piece. And I'll describe how we're doing that in just a moment. I believe Ken's going to help have me help him here in just a second. So this tool here that he's using is called a fuller, which is putting a groove around the piece right. So again, here's a section here, basically the step that we're just accomplished. We took a fuller, this tool here, drove down into that piece to isolate this mass. He's cleaning up that area on either side of that so we can essentially get this mass here in the middle so the handle can go on the one side and start shaping what's going to become the blade of this chisel on the other side. I'm going to have to stop here in a second and probably reheat this piece, and then we're going to use in the second heating of this, we're going to have to go in there and use another tool called a set hammer. We use a lot of top tools such as these that we can lay on top of the piece to do various tasks. You often have to use like somebody with a second hammer to actually strike the tool to help do shaping. And when we're using those types of tools, we're oftentimes the person leading the work is communicating oftentimes with his hammer itself. And there's taps to say when he needs help or when to start hitting or when to stop hitting or how hard or how soft. So there's that nonverbal communication that's happening while the work's going on. You just place the tool on the anvil. It's called a bolster. It's kind of at this stage now, and he's going to again use a set hammer like this. He'll lay that together, and he's going to squeeze those or isolate that material out to help control that shaping of that chisel. The purpose of that bolster is to give extra support for the handle, so this doesn't slide up in use. There's other types of chisels that also have similar features. Here's a mortising chisel here. that has a similar type of a feature. This one here was actually made in a different process. They actually welded a collar on to get the mass into place, opposed to making it out of one piece. Though you could have still made that out of a single piece if you chose to. And then here's a third option, whereas the chisel is actually made with a socket where there's an opening in the end of that, kind of like this piece here, that the handle goes down into it. You ready? So you see how the shaping of the hammer is just easily kind of pulling that longer and skinnier, cleaning that up just a little bit before he continues to the next step, making sure it fits into this tool. So here's the set hammer. He's going to place that exactly where he needs it, and then we'll use the sledgehammer to help clean up that shape. So with that set hammer, you can see how we, on that last heat, actually use that to actually squeeze this material down just a little bit, but also use it to clean up these shoulders here to make them more crisp and more defined. So it was kind of used in a lot of different facets in just that little small area. And I'll probably do a second round of that here in a second. Ultimately, what's going to happen is that's going to get taken down a little bit farther, where right now that's kind of a square. It's kind of hard to see in there. But that ultimately is going to be octagonal. So it comes down into an 8-sided, faceted section. I don't know if you can see that or not. So there's 8 sides, and then the facets also go down that way. So there's a decorative feature to it as well as a functional feature to it. And then you see that carrying over also out into the handle itself.
So Mark, we have a few questions starting to come in. Lisa, I think a basic question, was wondering about, how hot does the fire have to be to do this work?
Let me help Ken here real quick, and then I'll answer that question. Oops. So you say Lisa was the name? Lisa, the temperature of the fire is when Ken's adding air down into the fire itself, the fire is hovering in about a 3,000 degree Fahrenheit range of temperature, plus minus a little bit. But the actual working temperature of the fire itself is or the working temperature of the iron itself is roughly about 2,500 degrees down to about 1,000 degrees. And we're actually judging that by the color that the metal turns. So we're actually looking at the color more so than thinking about the actual degree of temperature. So a lot of these you're probably seeing like a bright yellow or almost a whitish in color. Once we get closer to the finished shape, you'll see lower temperatures like almost a dark red almost in color when we're trying to get a smoother surface. Oops. It is important for the striker to hit in this right spot too. Good.
Jordan was hoping to hear more about your sledge, your hammering technique, Mark. Could you walk us through what you're thinking? You know, what you're having to pay attention to. What's going through your mind when you're swinging that?
Right now, I'm thinking, don't miss, don't miss, don't miss. In this, I don't know. I'm not sure what my technique is. There's kind of different techniques that you're using in swinging the sledge when you're hitting a top tool like the set hammer, versus when you're just me and the other person are both hammering together. And when like Ken's using this set hammer and how he's holding that set hammer into the spot, sometimes I'm hitting like right in the center. Sometimes I'm hitting on one side or the other side because I want that to actually push that into the shoulder. And there's one time I did say a whoops because it kind of didn't push it in the right spot. So like right now I'm actually hitting kind of to the outside of that because I wanted to push it to the inside of that. And it's not always just hitting straight down. There is an element of control to a lot of what we do as blacksmiths and not just wailing away mindlessly on something. But sometimes we do have to hit stuff hard. But as you can see, I mean, if you gain the practice or gain the skill, you can go from a square bar into a finished shape relatively quickly. I mean, as blacksmiths, we're making this chisel, fairly quickly, probably in a half hour or so, plus minus maybe. This is a tool that oftentimes would have been made by a specialty trade in England. They might have had some specialty tools set up to speed up the work, but at the same time, with a very basic toolkit, we can still do it very efficiently.
Speaking of efficiency, that's also going to bring cost to mind.
Right.
Rob was curious about the different types of bolsters, whether it's welded on, part of the blank like we have here, or if it's a socket chisel. Do those three different bolsters impact the cost?
Not really. So I think in that case, yeah, the three different designs that I showed earlier, like the two different bolster types and the socketed type, time-wise investment, they're all about the same. And weight investment of materials is about the same. In the 18th century, a lot of the costs of these items seem to be more associated with the weight of materials, not how much time is invested in them. And I'm not saying our time's doesn't carry a value, but that seems to be the lower part of the equation. So for a local blacksmith shop in Virginia, oftentimes you're looking at around 9 pence a pound for selling our work or our wares, where that English-made import selling out of stores might be around 6 pence a pound. But sometimes you do make things a certain way because you can get it done faster. Sometimes it's just the materials that you have at hand. You certainly could make this by welding something on there instead of making it all out of one piece. Sometimes also part of that equation goes to the iron itself, because iron actually has a grain structure that runs the length of the bar. And sometimes you want that grain oriented in a certain way. So you might weld something on there because you want the grain in a certain direction. And if you did it like we're doing it now, that might work against you. In this case, it doesn't, but in some cases it might.
There's a question from Devin, maybe a little bit related to this, but where would a colonial American blacksmith be getting their iron and steel from?
That's a great question. The iron and steel were really local commodities. So as early as 1607, they're mining and refining iron in Virginia. By the time period we're talking about, the 1770s, it's a huge industry in the colonies. There's furnaces as close as 25 or 30 miles to the west of us. So not too far away. About 100 miles, I think, was about the closest furnace that was also producing steel. So we don't have to go far for our raw materials. The fuel that we're using, the coal, we could also use charcoal. They're also locally obtained. So the shop that we're dealing with does a lot of work for the military during the war, and that's one of the reasons our shop, or we as a nation, could be successful in going into that whole fight for independence, is because we have those natural resources to help outfit an army.
One of you was curious about who were some of the early American edge tool makers, and where would we find them? When do we start to see edge tools being made in America, and where are they centered?
That's a great question, and I don't have a lot of good sources right off the top of my head to answer that question. You're certainly seeing them throughout the country, and I don't have a lot of datable names and sources to throw at you, unfortunately. I mean, in Williamsburg, there is certainly a cutler in the 18th century, William Ashburn, that shows up for a short time, who's making edge tools. He's trained in, I believe it was London, and then shortly later, after about 3 years in business here in town, he moves to a bigger community because Williamsburg itself wouldn't support him. So in some of the larger towns, I think you're going to see more of that. So if you're in places like New York or Philadelphia, you're probably going to see more of that kind of thing. But in a smaller town like Williamsburg, probably less so. So in a smaller town, you're probably going to have to rely on a local blacksmith, such as ourselves, to carry out this type of an item.
Do you think in a town like Williamsburg, a woodworker is more likely to have something locally made, or they're going to buy it in a store?
I think you're going to see a combination of both stuff being locally made and bought in the store. So I think if you have the option of buying that chisel in the store and it's made in England, you're going to do so. But if you need it right now to get that job done and it's not available, then you might get the local shop to make it for you, even though it might cost you a little bit more. More often than not, you're probably going to be asking us to fix this chisel for you after you've sharpened it past where the steel is at. Earlier, we mentioned that this is made out of two materials, both iron and steel. Right now, we've only been working with the iron portion of it. I don't know if we can pick this up on the camera or not, but there's kind of a line right here on this piece. And it's shiny from right there and it stops right there. That's actually the steel section on the chisel. So that's the more expensive part of that. If you sharpen this, each time you sharpen this gets a little bit shorter. And eventually you get past where that steel is at, or you get up into a section that was hardened or heat treated softer, and then this has to come back to us for a repair. So a common repair would be to weld a new piece of steel on this, re-harden it, and re-temper it, and then give it back to the woodworker so they can use it for another 10 or 20 years, hopefully, depending on if they abuse it or not.
You discussed this a little bit, but Raphael was asking about the sources of tool steel in colonial America, as opposed to the iron. And then I'll also throw in, how likely are you to recycle something as a source of steel?
The recycling steel was certainly something, and iron, both are commonly done in the time period. One of the tools that we use in our shop often is files. So, and after we're done with this, there's actually going to be some filing that happens on this to finish up and refine the shape. Eventually, this file is going to get dull itself, and you can't sharpen it. So it's all made out of steel, so that will get recycled and made into one of these, they'll become the cutting chisel or cutting edge for one of these chisels or any number of other products. So that type of recycling is common. Matter of fact, I think the piece of steel that Ken has prepared for the chisel that he's working on, matter of fact, I think he's got the piece of steel right now that he's working on it. Is an old file that looks like he's preparing for this at the moment.
Yeah, maybe I can jump in here briefly, and you can still see some of the texture of the file in the piece of steel right here. And I'm working material to get the width and thickness I need for welding a piece of steel on. So on the next couple of heatings, once I've established the width and thickness, I'm going to forge a scarf on the end that will help blend the iron and the steel together. Then I'll cut it to length, and then we'll go ahead and weld that onto the body of the chisel. So that's what you'll be seeing over the next couple of heatings.
So as he's preparing this and getting ready to weld this, that process of welding that iron and that steel together is one of the more difficult things that we do in our trade. Like when we're welding iron and iron together, you're dealing with the same temperature. When you're dealing with steel and steel, you're dealing with the same temperature. But when you're dealing with iron and steel, you got two different temperatures you're dealing with, but they both have to be at their respective temperature. So he has to compensate for that by preheating one. So he's either going to preheat the iron so it's a little bit hotter, or he has to manage it where he has one in a little bit hotter or colder part of the fire. So the steel is at lower temperature piece.
So you'll also see here while I'm working the material that there are sparks that come off, and that's an oxidation that forms when the material's hot. When I want to weld two pieces together, I have to control that oxidation. So I'll scarf the end here. Next, I'll cut that to length, and then I'm going to use borax as a fluxing agent to control oxidation while I prepare to weld the two together. And then as Mark was saying, with this temperature differential, what I'll have to do is I'll flux the piece of steel while it's hot, and then I'll leave that on the anvil and allow it to cool off. So I'll measure out the length that I want here. I'll cut it. Cut most of the way through, and then I'll put some borax on it while it's still hot. That will melt and adhere to the surface. And then I'm going to break off the steel from the rest of the bar here. And then I'll set that right on the anvil and allow it to cool while I then heat up the iron body. And this is going to provide the differential. The iron, when I go to take the welding heat, the iron will be much hotter than the steel. And if I heat them up at the right rate, then the iron will reach its fusion point at the same time as the steel. And I can quickly bring them out to the anvil and hammer them together. So you see that here, just a few minutes.
We had a question from Kay about anvils. Do you have basically one type of anvil, or there are variations in the shop? If you could give us a little anvil lesson.
We do have a variety of anvils in the shop, both in size and slightly different styles. It'd be kind of hard to show you at the moment, but the anvils, the main anvils that we're using, like Ken's using at the moment, is based off an anvil that we know that was in this region in the 18th century. There was a blacksmith who purchased an anvil when he was setting up his shop. He bought an anvil made by maker Bird, and it was about 285 pounds, if I remember correctly. So in our collections, we actually have an original Bird anvil that we had duplicated, and that's mostly what we're using in the shop. And then we also have a smaller, let me hold that. We also have a smaller version of that style of anvil on our workbenches for doing lighter work when we're doing assembly type things, like when we're working on locks or other things. Some of those have horns on them, some of them don't. Some have fifth foots, which is an extra feature down on the side of the anvil, which is a carryover from earlier styles of anvils. Then we have some other anvils that have like different shapes. Sorry, I'll let Ken talk.
So quickly, you can see here the iron is very hot. The steel's at room temperature. I'll put a little bit more borax on top of that, and then we've got to go to the fire to heat it up to the welding heat.
I'm sure whenever you talk about making tools, you'll get this question like the one from Ryan, which is a good question. Do you make your own tools?
Yeah, as blacksmiths, we make a lot of our own tools. Probably 3/4 of the tools that we have in our trade, we make ourselves. Outside of our basic kit that we buy, you know, the anvil, the bellows, we make our own, most of our hammers ourselves. We make all the top tools that we're using in this process. We make all the punches, chisels, the tongs. Yeah, we make most of our own tools. Most of the time when we get asked to make a tool for the customer, we usually start the process by making 1 or 2 or 3 tools to make that job with. And so we're always accumulating more.
And Doug was curious about all the wood handles. Is that something that you would do, or does that get passed off to some other trade?
Sometimes we do it, and sometimes it's passed off to the customer. So if I'm making this chisel for the cabinet shop, we give them the blade, and then they can make their own handle. They certainly are capable of that. At least I hope so. But if I was making, say, an axe or a hatchet for the kitchen, you know, they don't have the tools to make that handle, nor do they have the knowledge to make that handle more than likely, so we would make that for them.
All right, so we're ready to do the weld. I've got to carefully bring this out of the fire and then quickly hammer the 2 parts together. So I'll make sure they're in line. And at that temperature, the iron and the steel will blend together, fuse together. So when you're doing that welding, you want the hammer blows to be quick and firm. And you can see that it's pretty well fused together. I've got a little bit of a cold shot right here, right at the end of the scarf. And so what I'll do is I'll take another heat and a welding heat and see if I can close that up. It's mostly a cosmetic thing. The chisel would work just fine with the steel welded as it is. But I'll take another welding heat to see if I can make that disappear.
There's a flatter after that.
Maybe.
John had a question about some work you all have done in the past. Are there any plans to continue on with the bloomery work?
Possibly. We ran a bloomery year and a half or so ago, and 2 years ago maybe was the last time we actually did one on the site. And we were actually discussing the possibilities of maybe running another one in the future. We were talking about it yesterday. So it's a possibility. I'm not sure when or where at this point, but yes, it's a possibility.
All right, so one more welding heat. I'll concentrate fairly light blows right along that scarf, that cold shut, to close that up. I've got some extra thickness in the material, so I'll stretch that out over the horn. Sometimes as we weld those two together, the iron being softer than the steel will stretch out beyond the end of the steel. And so what I like to do is I'll trim the edge square. And I can trim off any overrun of the iron. And then that also gives me a reference for which side the bevel will be on. So you see I've got the blade made, the steel's been blended in pretty well. Oops. Steel's been blended in pretty well. And now we'll get into the finishing touches. So that would mean marking it, smoothing it out with a flatter, and I'll do that at a low temperature with Mark's help.
Jordan was wondering if there are any, if you have any good tips to share about getting the scarf between the steel and iron to blend in well.
Make the scarf very, very thin. As thin as you can get that scarf, it's easier to blend it together.
So from Richard, in colonial times, was there any distinction between blacksmiths and farriers?
Yes. We know farriers was a specialized trade going back to at least the 12th century. So it's specialized even back that far. Though I think throughout history you see crossovers between farriers and blacksmiths. In this shop here, we don't see very much in the way of horseshoeing being done, but there is a little bit that shows up here. But there were people in Williamsburg that were running shops that only did horseshoeing that were farriers. So we do see that distinction in Williamsburg, even in the 18th century. So this tool here is called a flatter, which does what it says. It's going to smooth this out, take out any of those stray hammer marks that I'm sure Ken didn't leave behind.
Taking out the ones you left behind.
Yeah, probably.
Now you can see that leaves us with a pretty smooth surface. So here's the steel side. The steel runs back a little more than a third of the way about here. I cut it from this side, so it indicates that the bevel will be in this direction, so that as it's sharpened, the steel will be projecting all the way to the end, and then the iron runs the entire length. It's a laminate. Last step is we'll mark it.
At what point in the process, so Mike was asking, what would you do differently and how to make a curved gouge instead of a flat chisel?
So if we were going to make a curved gouge, we would use a tool like this here called a swedge, which fits into this square hole in the anvil. And then we could lay that forging over top of that, and use, a lot of times you could use your hammer sometimes, but we would use one of those fullers, and we could push that material right down into that. And that would make that curved gouge shape into whatever curve or sweep that you wanted. This last step is just marking it with the shop mark and personal mark maybe. A lot of times the date. In the work that we do in the shop, we try to put our shop mark in the year that we made it, so we know that it's not an antique until it is. We also know how long it's been abused when it comes back for repairs.
So again, with the finished piece, got a little bit of a curve to it. The finished piece, you can see the desired finish is that there's little or no evidence of the hammer in the finished piece. I've got the shape largely made so that it'll minimize the amount of time I have to do finishing work with filing, or there will be some grinding to polish the steel side. That will be necessary. But the closest you can get to the finished size and shape with a hammer, the less time you'll have to spend cleaning it up. And so over the course of, 20 minutes or so, we've gone from a square bar of iron like this to the forging for a chisel with the steel laminated onto it. So we can address other questions. What other questions do you all have? Please send us in.
Yeah, so Maria was wondering, how do you get the handle on there?
That section on the back, that spike or tang as it's referred to, actually gets driven into the wooden part. There's a hole in the wooden part that gets driven down into. So there's again, a hole that's driven in there or put in there, and then you just put the two together. So we could probably pull this one off if we really wanted to, though this one's not my chisel, so I don't want to do that.
And so if this work was being done in a shop of somebody who just made edge tools, would the process and equipment be much different, or is it essentially going to be like this?
Yeah, it's an interesting question. It's one we've been exploring because I think there were some specialized tools used to make these bolstered chisels. I suspect that that octagonal shape on the bolster is made by fitting the chisel down into a die, and then there's a tool that slips over the top of that, and that's struck with a sledgehammer so that we get the whole thing made very cleanly in that single step, rather than using set hammers and fullers as I was doing here. So that's, we talked a little bit earlier about differences between commercial manufacture and something made by a blacksmith. A shop like this that's set up really to do a broad spectrum of work, including manufacture and maintenance, wouldn't necessarily have those highly specialized tools that would be owned by a chisel maker. So I'm not saying that our chisels are exactly like the English manufactured commercial chisel that was being imported here. The end product will look very, very much like those, but our process is a little bit different than a professional chisel maker.
Got a lot of blacksmiths talking to each other in the comments, and some of our other CW blacksmiths are chiming in too. It might be a good time to ask you both, if you had the opportunity to set up a new blacksmith shop, as you did recently with this shop, what are for you a couple of important features that you want that shop to include? And I'm thinking of a traditional 18th century type shop.
Yeah, when we set up this shop, we had to take that into account. Some of the things I was pretty determined to accomplish. We rely, in a traditional shop, we rely on sunlight for our light. And so our vices are set at the workbenches, and they're set right under a window because we're relying on that natural light. And we were in an earlier reconstructed shop where the window height was about 2 feet above the bench. And the problem that the designers didn't anticipate is that casts a shadow on your workbench. So one of the things I insisted on was that the windowsill had to be within 4 inches of the top of the bench, and that gives the bench excellent quality light for all the detailed finish work. Also, I don't have to tell you all, but the height of the anvil and the height of the workbench, you want the anvil height to be about the height of your knuckles. Well, one of the other things I wanted to make sure we did was, once we set the anvil height, we wanted to make sure the brickwork was exactly at the same height. Because if you're working with a very long piece, that allows you to conveniently just lay the piece across the forge and the anvil without having them at different heights. So that's important. And then just the convenience, again, for the blacksmiths out there, you all know you want the fire, the anvil, a forging vise, and a filing vise to be all in pretty close proximity. So the layout was important. In this shop also, reconstructing an 18th century armory, security was important. So all the windows have double thickness shutters, all the doors are double thickness, it's sheathed inside and out. So we're trying to recreate the feel of that 18th century workshop as well.
Is there anything that you wish you had in here that you don't?
Well, we were discussing that earlier, the beer cellar I found an 18th century government blacksmith shop in England that had a beer cellar, but I couldn't quite convince the leadership here that we could have one in our armory. What about you, Mark?
I don't know, we settled for a beer attic.
Right. It gets kind of warm in the summertime, though.
That's true. Cider?
Blacksmiths spend so much time in the attic in the summer, yeah. Okay. So Michael and Mike both asked questions about heat treating or tempering the chisel. Tell us about that process.
Yeah, so we went through the process of applying steel. The whole reason we're applying steel is because we can change the hardness of steel. So heat treating is the process of establishing that hardness. In something that's very thin, like these paring chisels, the next step, well, there are really 3 steps. The next step really would be to heat this up to a red hot and bury it in wood ashes and allow it to slow cool. So slow cooling takes all the stresses from forging out of the material and all of the hardness out, leaves the steel as soft as it can be. We then heat that up again to a red hot and fast cool it. With a thin chisel like this, we do the fast cooling in oil. So in this period, it's usually a vegetable oil or an animal fat, so linseed oil or olive oil. Fast cooling steel makes it very, very hard, but also brittle. And then for tempering, a third heating, this time it's going to be much below the glowing temperature. So we'll heat up another bar, and use the radiant heat from that bar to heat up the edge of the chisel. And because it's below the glowing temperature, I'll look for colors of surface oxidation, what we call tempering colors. And as you raise the temperature in the tempering process, you're softening the steel back. And you want to reach the point where you're balancing hardness and flexibility so that the tool's suitable for its intended use. That perhaps is another show, although it's not quite as exciting to watch unless you add the drama of having the oil burst into flame.
Devin was wondering, are there any primary sources that you'd recommend for learning about 18th century blacksmithing?
There's Moxon's book on blacksmithing. What's the exact title of that?
Moxon is Mechanic Exercises.
Yes, thank you. Then there's just drawing blank.
Yeah, there are a couple of good books. One of the few period works we have that focuses on hand tool technology is Joseph Moxon. He wrote in the late 17th century. There were reprints of his work in the early 18th century. And within the last 10 or 15 years, there have been reprints of that made. So you can find a copy pretty easily, reasonably priced. There are other early works. Another one called Mechanic Exercises was written by a fellow named Peter Nicholson. And he has a section in there on iron and steel work. As for primary 18th century sources, there really weren't a lot because so much of this information, first of all, it's hard to write down all the detail you need to know in order to do the work successfully. So in the written word, you sort of get an outline of a process. You really still have to do the work to figure out the nuances of the work. So generally, people weren't learning through books. They were learning through apprenticeship, having a mentor that could demonstrate a process and steer you through the learning steps. And that's still often the best way to learn today, is to work with somebody that's already skilled at it. And then some of the best documents we have are actually old work. So if you study the old work and you can figure out how the material was manipulated to create a shape, that gives you insights into process.
You got books like Son that shows a lot of early old work.
Right.
Or
Albert Son wrote Early American Wrought Iron, a great sort of the Blacksmiths' Bible of American ironwork.
So I think we have time for one last question, maybe to jump from the past into the future. What's in store for the Blacksmiths in the coming year? Any big projects on the horizon?
Yeah, we went through, a few years ago, we went through a number of years, probably about a decade of big projects. We did the coffee house, we did all the buildings on the armory, we did the market house. It was a time of real exciting change. The past couple of years, there's been less of that, especially with COVID. It slowed everything down. We do have a couple of projects on the horizon, though. We're going to build a new drying shed for the brickyard as we sort of refurbish the brickyard operation and put them in close proximity with our carpenters. We have an opportunity in the next couple of years to reconstruct the First Baptist Church. Very, very important site here in town. It was the first organized African-American church. African Americans enslaved were meeting informally as they could, but here in Williamsburg, the First Baptist Church was founded in 1776, and the First Baptist Church community still meets in Williamsburg today. So we're exploring the site of that first church right now archaeologically, and in the next couple of years we'll plan on reconstructing that building. And then third, we also have the first school for African-American students who were enslaved, the Bray School. The original building still exists. It was discovered in the last 10 years or so on the campus of William and Mary. And so we're partnering with College of William and Mary to move that building into the historic area and restore that. And then we can tell the story of African American education starting in the 18th century. So a few exciting projects. And then we've got our regular work, producing tools and hardware for vehicles, household furnishings, cooking implements. So that's primarily what we've got on the horizon.
Thank you so much, Ken and Mark, for joining us all today. And thank you, everyone at home, for tuning in and sending in great comments and questions. This project was funded in part by a generous grant from the National Endowment for the Humanities, and as always, was made possible through the generosity of our donors. Thank you. To learn how you can contribute to presentations like this, please follow the pinned links or join us at colonialwilliamsburg.org. Mark and Ken, do you have any final thoughts to send us on our way today?
I'd like to just thank everybody for joining us today, and please join us in the future. Ken?
Yeah, I'd reiterate that. It's fun to see this stuff through the internet, but it's even better to see it in person. The blacksmith shop's open generally 7 days a week. We're closed today for this sort of special programming. And then, as I implied, there's always something new and exciting going on. People tend to think of history as being stagnant, and I've already heard that story. I don't have to hear it again. But as you learn more, your understanding of history evolves, and the story really is refined. So come back and see what we're doing here with projects like the Brickyard, the First Baptist Church, and the Bray School. We look forward to having you here.